Injection molding manufactures plastic parts for industries that range from aerospace to consumer electronics. With short cycle times and low-cost parts, it is one of the leading manufacturing processes for high-volume production. But to achieve that, injection molding uses sophisticated tooling that can take months to make and cost hundreds of thousands of dollars, so it is vital that design flaws are corrected before making molds. For many years, additive manufacturing, also called 3D printing, has produced prototypes for analysis of new product designs, but 3D printed prototypes could never meet the needs for full functional review using production thermoplastics. PolyJet addresses form and fit prototypes, and now functional prototypes in end-use materials. For form and fit, 3D print a part. For functional review, 3D print the injection mold. As an alternative to machine soft tooling, PolyJet reduces mold making time and cost by 50 to 70%. In the injection molding process, plastic is heated and injected into a tool, which has a core and cavity side. Although not made of aluminum or steel, the common metals for injection molds, the process is the same when using 3D printed plastic molds. The result is hundreds of molded parts in thermoplastics such as polyethylene, polypropylene, polystyrene, ABS, nylon, and many others. Since plastic molds behave a bit differently than metal ones, a few modifications are needed. During mold design, minor adjustments are made to draft angles and shutoffs, for example. Next, the core and cavity are printed on a PolyJet 3D printer. After some light sanding of the mold, it is ready for the injection molding machine when molded parts will be manually removed. For automated extraction, fit an ejection system, which uses pins that pass through the core to push a part from the mold, and then mount the printed tool in a mold base. Now, you are ready to injection mold parts. With a few adjustments to the machine settings to avoid damaging the printed mold, set the barrel temperature and injection speed to the low end of the recommended range for the thermoplastic. And since plastic molds don't cool as fast as metal molds, increase the duration of the cooling cycle and add a dwell between injection molding shots. After molding parts, just trim off the flash and gate to have fully functional prototypes for testing, analysis, and review just a few days after completing the product design. For further information, contact Stratasys Application Support.